Okay, section 11.2 box and whisker plots. First of all, what a box and whisker plot is it's a data display that organizes data into 4 different sections. So it categorizes it into fourths, lumps it into 4 categories. Now when we have it, it's actually going to look like a box and whisker. So this is a sample one. There's going to be a line down the middle, and then there will be something going out this way, something going out this way. And this is what our box and whisker plots are going to look like. Now each of these points have an identity. So the lower quartile is going to be this point right here. This is the lower quartile. The upper quartile is right here. The lower extreme is this lowest point. And if you just want to abbreviate, you can. And the upper extreme is right here. And the only point we didn't identify is right here, and this is going to be the middle of the data, so we're going to note it as the median. These are our 5 components that we're going to need to know when we make any box and whisker plot. So let's jump into example 1. It says a farmer recorded the number of oranges that an orange tree produced for each of the last 9 years. The data are given below. 572, 452, on and on and on. We need to make a box and whisker plot of this data. So basically what we need to do is we need to categorize it in chunks of 4. And that's what we're trying to do. We're trying to break our data into the 4 categories. And the first step says to order the data to find the median, the quartiles, and the extremes. So we need to find median, lower quartile, upper quartile, lower extreme, and upper extreme. These are the 5 things that we need to find. Okay, so first we need to order the data. So we can go through, it looks like 360 is the lowest. I'm going to cross it out so I know that I've used it. 380 seems to be next. And do you know what? As I did that, I noticed that I missed 264. That's actually the lowest. 264. Then I'm going to scan. I have 407. 452. 457, 458, 460, and 572. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That seems subtle just to go through and scratch them out and count it, but please, that's an important thing because I've seen so many people forget one number and it throws off all of your information. Okay, let's go ahead. We can identify the first one. The lower quartile is going to, or the lower extreme is the smallest number, so it's 264. The upper extreme is the highest number, so it's 572. Those two are going to be the easiest right off the bat problems to find. Now we're going to count in. We have 9, so if I go over 1, 2, 3, 4, you can come in this way. 1, 2, 3, 4. It's going to bring me to my median. So my median is 452. Then I need to find my lower quartile and upper quartile. Now the lower quartile is the median of this lower half. This distance here. We need to find the median. So really that's what's right in the middle. So I'm going to take these 2 numbers, add them up, and divide by 2. And when I do that, I get 370. You can kind of almost look at that and see it. You don't necessarily have to get a calculator and add them up. So we see 370 is right in the middle there. Now I'm going to do the same thing with my upper quartile. I find out what's right in the middle, basically the median of the upper quartile area. It's known as the upper quartile. So between 458 and 460 is 459. I now have all of my 5 components identified, and I'm ready to go ahead and plot it. Step 2 says plot the median, the quartiles, and the extremes below a number line. So I'm going to draw out a number line. Try to make use of this here. This is going to be my number line, and I'm going to use this to make sure things stay like uniform. I don't want to have my numbers jumping too much. Oh, that was an odd noise. There we go. Okay, so this is going to be, I'm going to make this, let's see, my values are ranging from 264 up to 572. I'm going to count by 50s. There's not really one necessary right answer, but we want to make it large enough that we're not writing numbers down forever, but also small enough that we don't have too many gaps in our data. So 250, 300, 350, 400. Alrighty, now that we have this here, you know what? I'm going to have to extend that line just a little bit. Okay, now we have our number line, and we need to, it says, plot the median, the quartiles, and the extremes below a number line. So we're going to use this number line to base things off of, like I said, to make sure that they are equivalent, so we're not jumping too many extremes. So our lower extreme, the smallest number is 264, so that's approximately right here. And obviously we're using 50 is a decently large gap, so it's not going to be super precise, but we're trying to get the general idea, estimating as close as possible. 264 right here, lower extreme. Upper extreme is 572, so right about there. Lower quartile is 370, so right in here. Upper quartile is 459, right about there. And my median, the only one, I've done this. I haven't done the median yet, which is 452. So it's a little less. My upper quartile is 459, 452. Okay, so now I have all of my parts identified. I'm going to draw a line through these middle three, connect those as though they're a box, and then extend my whiskers, and voila. Excellent, we are done. We should always label things. Any kind of data display we should label with a title of some kind. So this is the number of oranges grown from the orange tree. So I'm just going to call it number of oranges grown. Okay, and there we have our box and whisker plot. Let's go on to the next page. On this page, we're going to kind of identify what a box and whisker plot, how it's used. So before we jump into that, I want you to see here, I pulled this up. This is a stock page, and it shows the swing trading guide. It talks about different methods of trading stocks, but you can see here there's a lot of box and whisker plots. The only difference is they're turned vertically instead of horizontally. So we do it horizontally because it's easier to think of it along a number line from least to greatest, but they're going to use stock markets a lot, and this represents what the stock the low point, the high point, what it closed at, its upper quartile, lower quartile, different points of the chart. So I have a few other ones of these that I'll show you in class as well. But that's just so you can see that there's some good solid application to this. Now what this information means is how it's listed here, interpreting this box and whisker plot. Each of these segments, and you need to kind of listen carefully to this point, each of these segments are 25% of the data. So that means this here is 25%. This is 25%. This distance represents 25% of the data, and that distance represents 25% of the data. So each segment of our box and whisker plot is representing 25% of the data. And what gets confusing is the fact that people look at it and say, well, hey, how can that be? This segment is a lot longer, a lot, wider, covers more numbers than this one. This one's pretty small. How in the world can this equal 25% and this equal 25%? And that's an excellent question, but you want to kind of try to get beyond looking at it visually and seeing it as a space that it takes over, which I know is hard because we just did geometry, but you want to think of it as how dense it is. So for instance, this means, let's say we have 25 numbers that we're working with, 25 pieces of data. So let's change that to 20. 20 numbers, 20 pieces of data. Each segment is going to represent 25% of that. So 1/4 of our data. So that means each segment is going to contain 5 numbers. So there's going to be 5 numbers that fall in this range, 5 numbers that fall in this range, 5 numbers that fall in that range, and 5 numbers that fall in this range. So all our spacing is representing is